Hello guys, so today we are here to solve our daily lead code challenge problem that is of search and rotated sorted array. So in this problem, we are given an integer array. Okay, the input to this problem is this. We are given an integer array and we are also given an integer target. So two things are given to us. One is the integer array, okay, and then another thing is that target. So target is also an integer number. And this array is not just an ordinary array. There are some specific, attributes to this array. So this array is sorted in ascending order and it has got distinct values. And this is sorted, but it is also rotated. Okay. So sorted and rotated. So if you see that it is sorted and rotated at an unknown pivot index. Okay, so I mean to say, see this 0, 1, 2 is the array, and then after 2, 4, 5, 6, 7 should have come. But since it is sorted and rotated, that's why 0, 1, 2 is coming at the end of 7. Okay, so it is sorted and rotated in this sense. And we have to, do search in this rotated sorted array or sorted rotated array. And the constraint that we have to follow is that we need to do this in big O of log n time. Now, see, even though this array is sorted and rotated, see this array. So this array has got 8 elements. Okay. Yeah, this has got, this has got right now, it has got, 7 elements. Yeah, 7 element it has. So the mid will be this element 7. So if you see 4 to 7 is sorted and this 7 to 2, this part is not sorted. Okay, but this half 4 to 7, this half is perfectly sorted. Okay, and the other half between 7 to 2, 7 and the high index value 2, that this half is not sorted. So in this rotated sorted array, there is one invariant, and that invariant is that at any given iteration, at any given point of time, the array is divided into two parts. One part is sorted and the other part is unsorted. Because why it is unsorted? Because it is rotated. Okay, rotated at an unknown pivot index. And because of that, one half is unsorted, but the other half has that perfect sorting property. So keeping this in mind, we can write the code for this. And low is equal to 0, high is equal to nums dot length minus 1, mid is equal to -1, and then we'll get inside our loop. Low is less than equal to high. Okay, mid is equal to low plus high. Okay, so here we are doing unsigned right shift, and this we are doing to avoid integer overflow. And after doing this, we'll put a check if the value at the mid index is equal to target. If it is equal to target, we don't have to do anything. We just return mid. If not, else what we will do that we will exploit the invariant of this problem. The invariant of this problem is that at any given, point of time or at any given iteration of this while loop. In this while loop, we are, narrowing down our search space by suitably modifying the low and high value. and at every point we are calculating the mid. So the invariant of this problem is that at any given point of our, our iteration, this array will be divided into two parts. One part will be sorted and the other part will be unsorted. And this will hold from the first iteration to the last iteration. Okay. And the other, this is the property of the underlying array. But what we are going to do, how are we going to exploit? So we will always, look into the sorted half first and try to ascertain whether the target is there in that sorted half. If it is there in the sorted half, then we'll, search as usual binary search thing. Okay. If it is not there, then we'll modify our, high or low index value suitably, so that in the next iteration, we'll recalculate the mid value, and again, a still narrower search space will be resulting with the modified lower high index value. And in that narrower search space, we'll again calculate the mid value. And then in that new subarray, there will also be a part of that new subarray which will be sorted and the part which will not be sorted. And in that still smaller part which is sorted, we'll again look into the, search for that target. If it is there, if it is not there, then again we'll, divide the unsorted part into two parts and look into that. So this is how we will be progressing in this array. So first of all, how are we going to check whether a given half is sorted or not sorted? So it's pretty, if a given half is sorted, then nums of low is going to be nums of low is less than equal to nums of mid. Why I'm using less than equal to? It could be a possibility, okay, that all the values are same. Okay, 1 1 1 1 1. Okay, here it has mentioned that the values are distinct. All values of nums are unique, so we can drop this value. But if it is not, then we have to use it. Okay, so in this again we'll have to check if nums of low is less than equal to target. Okay, and nums of nums of mid is greater than target, then will be high is equal to mid minus 1. Okay, else if it is not here, then low is equal to mid plus 1. Else, now see, this else if is giving one condition that the left half is sorted. The else of this condition is the left half is not sorted, but the right half is sorted. So this is telling sorted left half. This is, ascertaining that the left half is sorted. So it is determining whether the left half is sorted or not. And this else part is determining the right half is sorted. So it is telling sorted right half. Okay. So at every step, we are determining which half is sorted. And then in that sorted half, we are trying to figure out whether the target is within that sorted sub-range determined by either the low or high and the mid. So how are we going to do the, that determination here? So let me again come back to this. Okay. So if nums of mid, notice I'm using greater than, and here also I'm using less than. So mid here, the target here is less than the mid, and here the target is greater than the mid. And target is smaller than equal to nums of high. So you see, I'm using with the low and high, I'm using greater than equal to, you know, uh, less than equal to. Okay, so why I'm using equal to with the low and high? Because in this mid is equal to target. If mid is equal to target, it will be returned in the line number 8. So the thing which is left from the condition at line number 7 is that it could be from low to mid, but not equal to mid. So mid is not included in any of these two conditions. So I hope it is clear to you all. And then mid high. So high is equal to low is equal to mid plus 1, else high is equal to mid minus 1. Okay, return minus 1. So I hope it's clear to all of us, and but let me first run this, and see whether we are able to, we are getting the correct output or not. Perfect. So I have not used this, sorted, less than equal to. The sorted have can have repeated same values. So I'm not using that condition because the constraint specifies that all values of nums are unique. So I'm just using here that loose interpretation of sorted thing. Okay. Loose interpretation means low is strictly less than the value which is coming after. The value at low index is strictly less than the value at the mid index. They all could be same. If it is sorted, they all could be same. And that's why we use non-decreasing, not just that increasing thing. Okay. Okay. So see here. Okay. So here there is one issue. Target is 1. Okay. If I use equal to here. Okay. So you see, even then we have to use this equal to. Right. Perfect. So if you have any doubt, please, let's push it in the comments and I'll try to answer those. And this solution is beating 100% of the solution. So as of now, this is one of the best solutions that we can have. If you have any other doubt, please post it in the comments and I'll answer those doubts to the best of my abilities. Thanks a lot.